Problem number 4. Consider the differential equation dy dx equals y squared over x minus 1. Part A, on the axes provided, sketch a slope field for the given differential equation at the 6 points indicated. So I notice we have 0, 0, 0, 1, 0, 2, and then we also have 2, 0, 2, 1, and 2, 2. So I'm just going to calculate the slopes. Remember, this is just slopes, so I'm just going to plug things into that formula. I'm going to get the y squared will be 0 squared over 0 minus 1. That will just give me 0. So at 0, 0, we will have a slope of 0, so just a flat line. At 0, 1, we'll have 1 squared over 0 minus 1. That will give me 1 over negative 1, which will be negative 1. So my slope at that point will be negative 1, so something like that. Okay, 0, 2, we'll get 2 squared over 0 minus 1. 2 squared is 4. 4 divided by negative 1 is negative 4, so we'll get a steeper slope there. Still negative. 2, 0, if I plug 2, 0 in, I will get 0 squared over 2 minus 1. That's going to give me 0, so this one will also have a slope of 0. 2, 1 will be 1 squared over 2 minus 1. That will give me 1 divided by 1, which will be 1. So that slope will be a positive 1. And then 2, 2 will get 2 squared over 2 minus 1. That will give me 4 divided by 1, which is positive 4. So this one will, and there we go. Okay, that one was worth 2 points. You got 1 point for identifying both places where there's a 0 slope, and then you get 1 point for having the other correct slope. So that part was worth 2 points. Okay, part B, let y equals f of x be the particular solution to the given differential equation with initial condition f of 2 equals 3. Write an equation for the line tangent to the graph of y equals f of x at x equals 2, and then use your equation to approximate f of 2.1. So it's not asking me to solve it here, it's asking me to write an equation of the tangent line. So before I try to do anything else, I know my answer has to be y equals mx plus b. Alright, so let me see if I can identify my parts. My x, did they tell me? They told me, yep, f of x at x equals 2, so my x is 2. What about my y? They did tell me that f of 2 equals 3, so my y is 3. And my slope, my m, is going to be my slope or my derivative, which they told me, dy dx. So, and I know that that's going to be happening at the points 2, 3. So I can plug those in. So I'm going to get 3 squared over 2 minus 1, and that is going to give me 9. So I have all of my parts. Now all I need to do is plug it in. So I'm going to have 3 equals 9 times 2 plus b. 3 equals 18 plus b. b equals negative 15. So when they ask me for the equation of the tangent line, it's going to be y equals 9x minus 15. Okay, that would be worth just 1 point. You either got it or you didn't. And then I'm not done because it says to use your equation to approximate f of 2.1. So that's just telling me to let x now equal 2.1. So approximating that, I'm going to get f of 2.1 is approximately 9 times 2.1 minus 15. This is a non-calculator section, so try this out by hand. Make sure you remember how to multiply decimals. 9 times 2.1 will be 18.9 minus 15, which gives me 3.9. Okay, and that was also worth just 1 point. You either got it or you didn't. So this part of the problem was worth 2 points. Okay, part C, find the particular solution. So now they're finally asking me to find the solution to the given differential equation with initial condition f of 2 equals 3. So now we get to cross multiply. So we are going to get x minus 1 dy equals y squared dx. Notice that I do not have my variables matching up, so I'm going to divide both sides by y squared. So I'll have x minus 1 dy over y squared equals dx. Now I have to divide both sides by the x minus 1. So now I have dy over y squared equals dx over x minus 1. I am now allowed to take the integral. On the left side, I'm going to rewrite this. I'm not going to do a u substitution because I can just bring the y up. And on the left side, I am going to do a u substitution. So u will equal x minus 1, du will equal 1 dx, which I do have the 1 sitting there. So this is actually going to turn into a du over u problem. Okay, the integral of y to the negative 1, add 1 to it, and reciprocal on the outside will be negative 1 y to the negative 1 equals the integral of du over u will be ln u. So this will be negative 1 over y equals the natural log of my u, which was x minus 1 plus c. One thing I would like to do is I don't like having that negative there, so let's just multiply through by a negative. I'll get 1 over y equals negative ln x minus 1 plus c. And before I solve for y, I think it will be easiest if I find c. So they did give me this initial condition, so I know my y value is 3 and my x value is 2. The natural log of 1 is 0, so I know that c equals 1/3. So I now have 1 over y is equal to negative ln x minus 1 plus 1/3. Okay, we need one more point by solving for y, and I found out that, well, this was 1/3, sorry. Complex fractions were okay because they had it in their answer, so I'm just going to take this all and put a 1 underneath it so I can cross multiply. So when I do that, I get, I'm going to come up here now, wrote too big I guess, I get 1 equals y times negative ln x minus 1 plus 1/3, and then to get y by itself we'll just divide by that on both sides, so I'll end up getting y equals 1 over negative ln x minus 1 plus 1/3. So that will be my answer solved for y. So that part was worth 5 points. You got 1 point if you separated the variables. You got 1 point for correctly taking the integral of the left side, 1 point for taking the correct integral of the right side, 1 for using c and finding c. So if you put plus c and found it, even if you didn't find it correctly, that was worth a point. And then if you actually solved for y and came up with this as your answer, that was worth your final point. So that part was worth 5 points.